Hi everyone, welcome back to Codeviento. I'm Nihan and today we are going to implement a queue class in Java using a linked list as underlying data structure. Before we jump into the implementation, let's talk about why queues are important and why we are need to implement them in Java. Queues are everywhere in software development. Some real-world application includes test scheduling. Operating system use queues to manage running process efficiently. Request handling. Web service process incoming requests in a queue to ensure fair execution. Print jobs. Printer manage multiple print requests using a queue structure. Messaging applications like WhatsApp and email services use queue to handle message delivery. OneJob provides a built-in queue interface. Why we'll implement it in Java? Implementing it yourself helps you understand how queues work under the hood. And this knowledge is essential for coding interviews and performance optimizations. By the end of this video, you'll have a fully functional queue class with methods enqueuing, dequeuing, picking, and checking if queue is empty or full. Let's get started. A queue full of first in first out principles, just like a line of people waiting for service. The first people in the line gets served first. In programming, queue supports two primary operations, enqueue and dequeue. Enqueue adds an element to the end of the queue. Dequeue removes an element from the front of the queue. Other useful operations: pick. Check the front element without removing it. Is empty. Determines if the queue is empty. Has space. Check if the queue has room for more elements. We'll now implement this method step by step using a linked list. But before we begin, pause the video and try implementing them by yourself. Then continue watching to compare your solution with mine. We'll be using the linked list implementation from our previous video to handle dynamic memory allocation. Let's start by defining our queue class. We need three main attributes: linked list, size, and max size. Linked list stores the elements. Size the number of elements in the queue. Max size sets an optimal limits for the queue. We'll implement an empty queue with a default or user-defined maximum size. Let's start with to implement helper methods. Is empty and has space. Has space ensure there is more rooms for elements. Is empty, check the queue is empty. And we will use maximum size and size for the method implementation. Here is the implementations. If size less than maximum size, it means there is more room for more elements. If size equals 0, it means queue is empty. Let's implement enqueue method. This method adds an element to the end of the queue. First, we check if there is a space. We use add_to_tail from our linked list class to insert the element. Finally, we increase the size counter. Here is the implementation. If a space, add_to_tail, increase the size, and if there is no space, throw an error, queue is full. Let's talk about the dequeue method implementation. To remove the front element, first check if queue is empty. Then we use remove head from the linked list class. Finally, decrease the size counter. Here is the implementation. If it's not empty, remove head and size decrement. If queue is empty, throw an error. Let's talk about the pick implementation. Return the front element without removing it. If queue is empty, return null. If queue is not empty, return the head of the data value. Here is the implementation. I'm using linked list class we implemented before. If you want to watch it again and if you want to remember, you can watch linked list class implementation video. Here are the attributes and constructors. The helper method is here, has space, is empty, and queue, dequeue, and pick methods are here. Okay, here are the main class, and we will create queue with maximum file size, and we will add three elements, first, second, and third, to our queues. And when we pick the first element without removing it, when we check what is the first element, it should be first. When we dequeue the first element, when we remove the first element from the queue, it will be first again, because The rules is first in first out, and then we dequeue the second element. When we remove our second element, it will be second. And when we check if the queue is empty, no, it's not, because we have still the last element, it's the third. Then when we remove the last element and check it's empty, yes, it will be empty. Let's run our queue main class and check the result together. Pick the first element, it's first. DQ, yes, it's still first, and we remove the first also. Then when we remove the second element, it's second, and it's empty. No, still we have the third one. And then when we remove the last element here, and we check again, it's empty. Yes, it's empty. And our implementation is completed here. Great job! We have successfully implemented queue class in Java using linked list. We now have all essential queue operations, and queue peak is empty and has space. Queues are used everywhere, from managing programming in operations system to handle customer services requests. Understanding queue will help you become a better problem solver and software engineer. If you found this tutorial helpful, don't forget to like, comment, and subscribe for more in-depth data structure and algorithm tutorials. Thank you for watching, friends. See you in the next video.